Hello everyone and welcome to the next section. This set of directions says solve each right triangle. And I just want you to think back, what does solving a right triangle mean? You know that a right triangle has been solved when you know all of the angles. So you have three angles known and three sides known. So what this is going to do is it's going to allow you to use trig and the Pythagorean theorem to find missing pieces. And there were two situations. There was one situation that you could solve a right triangle where you had at least two side lengths. So that would fit like number 17 and 18. Both are given side lengths. So we need the other side length and the other two acute angles. And then there was a situation that fit number 19 and number 20. I'm going to call that my heart situation. We did that in class. That number 19 and number 20 were where you were given a single side length and one of the acute angles besides the right angle. And so I gave you two of each of these. This is important though. Let's keep reading our directions. We went around the side lengths like we did on the front of the paper. The side lengths to the nearest tenth, meaning one after the decimal. And then we went around the angles to the nearest degree per the directions. So don't round everything to the same thing. If it's a side length, we're going to round it to the nearest tenth. If it's an angle, we're going to round it to the nearest degree. Okay? Okay, so let's look at our very first problem, number 17. Let's see if I can zoom it. Move this. So number 17, we are given two side lengths. And the easiest thing to do is to start by finding that third side length. We have a theorem called Pythagorean theorem that allows you to find missing pieces of right triangles when you have 2 out of 3. And it's a squared plus b squared equals c squared. So what am I missing here? I'm missing a leg. So that x, I'm going to fill in for the a squared plus the other leg squared equals my hypotenuse squared. Well, what is my hypotenuse? My hypotenuse is 14. So I'm going to go ahead and label that from the beginning. That needs to go where c is. So that's going to be equal to 14 squared. Okay. So to get x squared by itself, we're going to subtract 4 squared from both sides. This is not, I want to make sure I say this because a few of you have done this in the last test. This is not 14 minus 4 squared. You can't make that 10 squared. This is 14 squared minus 4 squared. So if you type that in your calculator, it will do order of operations for you. But remember that 14 squared, we have to do 14 squared before we do minus 4 squared. That is 196 minus 16. So 14 squared minus 4 squared. So just be careful with that. That is going to be 180. So x is going to be equal to the square root of 180. We're going to take the square root of both sides. And so x is going to be about 13.4 to the nearest tenth. Again, make sure that that makes sense as an answer. Go put that in the picture. Is that less than the hypotenuse? It is. So side length NO is going to be about 13.4. We just put an x above that when we solved for it. Okay? So then how do I find angles, my acute angles? I have the 90-degree angle, so I'm just going to pick this one. You could choose either one. So I'm going to call angle N theta. I'm going to use inverse trig. Now, I know that I have three pieces there. I've got a 13.4, I've got a 14, and I've got a 4. But what are my only ones that were given? The 4 and the 14 were the only ones that were given. So I know for sure that those are correct values. So I'm going to work with the ones that were given instead of the one that I found. Just because human error, I could have made a mistake. So to find theta, I know that I'm going to use some inverse trig. So opposite and hypotenuse is going to be equal to the inverse sine of 4 over 14. How many degrees does that give me? Again, we're going to round this to the nearest whole number. So 4 divided by 14 is going to be 16.60. So that's going to round up to about 17 degrees. So if that is 17 degrees, how do I find my last piece? How do I find this star angle, angle M? The measure of angle M is going to be equal to 180 minus the 90 I spent at the right angle minus the 17 degrees I spent right here. So that is going to give me a total of 73 degrees for the star angle. So here were my two angle measures, 17 degrees. We had 73 degrees in the right angle. So there's the three known angles. And the side lengths, the 14 was given, the 4 was given, and I found the 13.4. So we have now solved this right triangle entirely. All right, this is the exact same thing. So the only difference is on this one, what I was looking for, the x was a leg. What I'm looking for on this one is the hypotenuse. So I'm going to call GM, I'm going to call that side C from the beginning. So that when I plug this into the Pythagorean theorem, I remember the C has to be my hypotenuse. So that's going to be 41.25 squared plus 125 squared equals C squared. I'm I'm going to type this whole thing into my calculator. 41.25 squared. Make sure I don't miss the decimal. 0.25 plus 125 squared. This gives me a huge number, and I'm going to take the square root of that number. That is going to be the square root of, let's see, it's 17,326. So when I take the square root of that with everything on it, it is going to be 131.6. Now we want to make sure that that makes sense as an answer. If this is the hypotenuse, would 131.6 make sense as a hypotenuse? Is it bigger than 125 and 41.25? And it is. That's about 131.6 rounded. Okay, so there's my other leg. Now I have all, or my hypotenuse, my other side, I should say. I already had the two legs. And so now I have all three sides. The only thing I need to find is one of the angles. So I'm going to go to angle M. That's just the one I'm choosing. From angle M, my known pieces from the beginning, where 41.25 would be opposite, and then 125 would be adjacent. That's the two legs. So I'm going to use some inverse tangent. Inverse tangent of 41.25 over 125. So inverse tangent, since I'm solving for angles, is going to be second tan 41.25 divided by 125. And that's 18.262, so that is going to round down to about 18 degrees. Okay, so that is angle M, that's 18 degrees. So if angle M is 18 degrees, we rounded that to our nearest whole number. How do I find angle G? I'm going to put that in a heart. How do I find angle G? That's 180 minus 90 minus the 18 degrees that I just found. That is going to give me a total of 72 degrees for angle G. Okay, so there's the other two angles and then that third side. So that was a situation where I was given two of the sides of the triangle. These next two are a little bit different because now I'm not given two sides. I'm given one side and a known angle, 51 degrees. Okay. So the first thing that's easiest to do is to find that other angle because I already have 2 out of the 3. I'm going to go ahead and find the measure of angle A from the beginning. So I'm going to do 180 minus 90 minus 51. It's really going to be the complement of 90. You could go ahead and just do 90 minus 51. That is going to be 39 degrees. So rounding that to the nearest whole number, 39 degrees is my star angle. Okay, so now I just need to find my missing pieces. Duke, stop, buddy. Sorry, y'all, that's my dog. Come here, Duke. Come here, Bubba. Okay, so how do I find AB? They want to find AB and they want to find AC. Okay, so what we're going to do is we're going to put variables there. So if I wanted to find, let's say I just wanted to, y'all are so used to working with the opposite. Let's say I wanted to find this one first. I'm going to put an X there. I'm going to put an X there. So what is X to 51? It is going to be opposite. And then what is the given 3? That is going to be adjacent. I'm going to be using normal trig here because I am solving for a side length. X is my opposite. So what is opposite and adjacent? That is going to be tangent. So the tangent of 51 degrees is equal to opposite over adjacent. And then I'm going to put this over 1 so that I can cross multiply. And so when I do that, X is going to be equal to 3 times the tangent of 51 degrees. So let's type that in. Now I'm solving for a side length, so remember the directions told me to round that to the nearest 10th. So that is going to be about 3.7. Does that make sense as an answer compared to the other leg? Yes, it does. That was AC, so that's about 3.7. Okay. At this point, you have 2 different directions you could go. If this is 3.7, you could use Pythagorean theorem and do a squared plus b squared equals c squared. I will write that on here later, but I prefer to use trig, okay? So if you went the Pythagorean theorem route, you could go 3 squared plus 3.7 squared equals c squared. So that's the Pythagorean theorem route. I'll show you in a second that it's the same. Or we could use trig again. So if I'm solving for my c value, I'm going to be working with the adjacent and the hypotenuse. I'm going to work with the ones that were given because those are for sure more accurate if I didn't make a mistake. So I'm going to work with the 3 and the c. So from 51, that's cosine. So that's going to be the cosine of 51 degrees equals adjacent 3 over hypotenuse c. Again, we put this over 1. We cross multiply. C is going to end up being multiplied by cosine of 51, so I'm going to have to divide by the cosine of 51. So C is going to be equal to 3 divided by the cosine of 51 degrees. So let's type that in. 3 divided by cosine 51. That's going to give me about 4.8. So 4.8, does that make sense as an answer? Is that bigger than both of the legs? Yes, it is. But what I want to do is I also want to show y'all that this would have worked had I done Pythagorean theorem as well. So when I type this into my calculator, 3 squared plus 3.7 squared, 3.7 squared, you get 22.69, and you take the square root of that. Whenever you do that, that is 4.76, so that also is going to give me 4.8 about. Okay, to the nearest tenth, that's going to give me 4.8. So you would have gotten the same thing either way. I prefer to use trig twice just because it's what I'm used to and it's what I've been doing. But a lot of y'all love the Pythagorean theorem. Y'all got really good at that. And so if you would like to do it either way, you will get the same answer. Okay. Number 20 is the exact same. It's given an angle and a side length, and we're just given an acute angle and a side length. It's just different numbers. Okay, so let's get started. Easiest thing to do is to find this other angle, angle K. So how do I find angle K? I'm going to do 180 minus 90 minus 23. That's using the triangle angle sum theorem, or you can just say, what is the complement of 23? We know that the complement of 23 is 67 degrees. 67 degrees, so I already have one of the angles. We rounded that to the nearest whole. And then I want to find the missing pieces. So what is KL? KL, I'm going to put an X there. That is going to be my opposite over my 5, which is currently my hypotenuse. So I'm going to be using normal trig. That's going to be the sine of 23 degrees equals opposite over hypotenuse. We put this over 1, and we cross multiply. So X is going to be equal to 5 times the sine of 23 degrees. 5 sine 23 is equal to, let's see, what does this round to? We want to round to the nearest, on these we want to round, it says, to the nearest tenth. So that is going to round 1.95. That's going to round up to about 2.0. So does that make sense as an answer? It does, because it's less than the hypotenuse of 5. So again, at this point, you have 2 directions you could go. I'm going to put a Y right here. This is about 2.0. About 2.0. At this point, you could go Pythagorean theorem, which would be 2 squared plus y squared is equal to my hypotenuse squared, which is 5 squared. Okay, so y squared is going to be equal to 5 squared minus 2 squared. And so when you do that in your calculator, 5 squared minus 2 squared is 21. Square root of 21 is about 4.6. 4.6. So that's how you would do it with the Pythagorean theorem. Or you could also do trig. So from this 23 degrees, I have my adjacent and my hypotenuse. And so I'm going to use cosine of 23 degrees equals y over 5. Put this over 1 and cross multiply. You get y equals 5 times the cosine of 23. 5 times the cosine of 23 is going to be equal to also 4.6. Okay, so either way you want to do that, you would get 4.6. So that is solving right triangles. There are 4 examples of finding the 3 known angles and knowing 3 sides as well.